My name is Scott Donovan, and I guess you're here to hear what I have to say on color calibration for digitally printed textiles. If you're not here for that, you're on the wrong plane. Please check your ticket. So let's get right down into it. Kind of explaining color calibration and color management, and I boil it down into color management as a controlled conversion between different color devices, whether it be your file or your monitor or expectations back to your print device. And it allows the printer to accurately predict color and color output through their particular devices and processes. Without color management, we get this a lot. These guys up here, not color managed, they ran into problems with customers. You'll notice we've all seen this on TV. Lots of them will crash, some will sneak through, and that's just the nature of color management, of doing it and not doing it. So the elements of color management, as I see it and it happens as I'm out helping clients color manage their devices or doing calibrations or profiling, and I boil it down into about 5 things. The one at the top is expectations, and we'll kind of get to that last, but we have the digital workflow, color calibration, process variables, and consistency, which is a big one that goes along with expectations. Color calibration, it's kind of the meat and potatoes of getting good color on your textile printing. And the main goal is to accurately map and be able to predict the results of your print processes. If you put a value in your file, you want to know what to expect back off in the printed fabric. And the calibration can be a standalone calibration if you have your own, just a single line of textile printing, or you can calibrate back to different lines and different processes. The factors of calibrating textiles. In here, we have a few elements in here. We have your printer. We have your RIP software. We have the substrate, the inks or the dyes that go onto the textile. Your post-finishing operations along with pre-finishing. And again, that expectation word is kind of creeping into to the process here. So the color calibration process steps that I take my clients through, and is a kind of a good rule of thumb to follow with any processing, any color calibration processes, is the first thing I like to do is I like to know how much dye my substrate can hold or ink. I don't want to over ink it, which will lead to pooling, and your clarity and the sharpness will go away. And I don't want to put too little of ink on it, because I want to get the optimum amount of ink on that substrate, so then when I get down to my color gamut, I have a lot of dye or saturation color and hue and chroma there to work with. This is a target through an ErgoSoft RIP, and it's just varying levels of overprints and how much ink is overprinted onto them. You notice on the left side there's a white background, and over here on this side there's a gold background. It kind of simulates overprints with a background color. The next step after I figure out how much dye or ink the substrate can hold is what I'll go to is linearization. And if there's anybody familiar with just old printing that's been around for a while, we're all used to grayscales, the little 10 or 12 step grayscale we used to use in photography on the process camera or in printing in general. Linearization just takes you and the printer through a process where it tells it that if I want to print a 50% dot, that my printer is actually printing a 50% dot. Because you got to remember, printers are only as smart as the people running them. So that printer out of the box may not be calibrated to print a 50% dot in the areas that you need it, and so forth up the scale from 0 to 100. And we'll do that with all the colors, whether it be the process colors or light process colors or spot colors or spot dyes that go into the printer. I don't know if you can see here, but when you get a bad linearization, there's a light spot right here. See how it starts out light there, and we're supposed to work evenly out to a nice sharp black here. About through here, something was wrong with that last calibration. This is an example of what happens when you get your linearization wrong. So right around here in the 85% area, it's probably looking more like 65%. So if you're running CMYK on your printer and you have a color that has 85% black in it, the printer's only printing a 60% dot or that equivalent, so that color is going to be wrong coming out of the printer. Back on linearization, if you want to get a little technical, we just have curves. This is what we want to print. That's the ideal value for that curve, and we're just trying to make a nice smooth curve so we don't have any spikes or valleys in it. After that, we can get into some graphing software which will show us the color hue or how those steps are set up on in the color space. And then after after we find out how much dye or ink the substrate can take, and after we do a linearization, then we get into the ICC generation. Those of you that have been around color calibration, you see the technician print out charts of blocks of color. What this chart is doing, the calibration software you're using has a theoretical yield of what the printer is going to output. But we know when the dyes are different colors, your post-finishing operations are different, your pre-treatment's different, or if you change substrates, it has a different white point or is taking the dye differently, that those linearization points that we put in may change a little bit. And those little minute changes will change what the RIP thinks the output is going to be. So what the ICC profile does, and when the person doing the calibration measures in all these colors, is he's just telling the calibration software that this magenta that you have a certain value on is actually printing on your printer another value. So he'll go through a series of charts, maybe 1,000, 1,500 spots, and it'll go through a calculation where then the calibration software says, oh, I have the value of X for this spot, and you're printing a value of Y. I have to do a calculation to mathematically get back to X. In a nutshell, that's an ICC profile. We have some considerations that go into effect for calibration. Again, machines and software basically only as smart as the people using them. So we have to take into consideration some images. The first one is what types of images are being printed. I kind of boil it down. I have clients that do process images, and I have clients that do a lot of flat colors. So I'll approach each one of those outputs a little bit differently. Take into consideration if I have any legacy calibrations that I need to match. Maybe a customer got a new printer, or maybe they changed their die sets, maybe they changed their fabric. So I'll take that into consideration. And then I also take into consideration if the RIP I'm using is generating the software, generating my ICC and my linearization files. And I'll talk about that in a bit. Another element up there for color calibration was a consistent digital workflow. You want to know, now that your printer's calibrated, and you know that I'm going to put value X in, I'm going to get value X out of the printer. Now I need to start looking at the files that I'm putting into my RIP. Do you have an operator that's taking the file straight from here down to this step, and he's missing some steps through there? Maybe there's some color conversion. Maybe you have some certain specs that you make your customer's file as setting up files into what color space you put them in. That all has to be consistent. And again, it's about consistency, putting known items into the RIP or into the printer and getting an expectation back out of it. We have our printing variables. So we have our fabric, different white points, different saturations, different weaves. If you're going onto a flock, there's so many different fabrics out there. Each of them take the color a little bit differently, and even when they're done, you might have a sheen on one where it looks different color if you're looking at the warp one way or the weft the other way. We have pre-treatment and post-treatment processes that can change color very easily. And then we have the print environment itself. If your temperature and humidity are fluctuating all over the place, I hope you're not printing in an environment that looks like this. Temperature and humidity with an inkjet printer is very important to keep those stable. We have the post-processing variables. As it goes through the steamer or a heat calendar for any of the dye stuffs that are out there. The big factors here are time and temperature. 5 degrees in 10 seconds on the heat calendar, I can change your color. So we want to make sure those are all set up and your post-finishing operations are very consistent. The last thing I want to talk about is expectations versus reality. Lots of times working with customers, you have designers, they want that PMS 485, or the printer's nightmare, the reflex blue. Some printers and some processes out there just can't get to those colors. So it takes a lot of education and expectation, kind of education on the front end with your customers or the technicians on the front to educate your customers on what to expect from your process. Lots of times with color matching, I kind of take an old school approach to it. I'll actually print out a color book and I'll give that to the designer. And then the designer knows if they see this color printed on that fabric, that color is attainable. Other clients that don't understand the expectations, you have trouble with those, so you just have to manage those expectations of your process and your clients. So kind of a real quick blow through on calibration and what to expect. Like I said, with textiles, there's a lot more variables out there than there are with a direct to solvent or water-based printing.